Welcome to the Professional Data Engineer Crash Exam course. Today we will focus on Dataproc, where we will be architecting managed Spark, Hadoop, and big data ecosystems. When data outgrows single machine memory, we face the monolithic limit. The distributed paradigm solves this by decentralizing compute across a managed cluster for partitioning data, task coordination, fault tolerance, and capacity allocation. The core of the classic big data stack includes MapReduce for parallel processing, Yarn for resource management, and HDFS for distributed storage, which replicates data blocks 3 times for fault tolerance. Building upon the Hadoop foundation, Spark is a fast, general-purpose distributed computing framework. Hive is used for data warehousing and translating SQL, and Pig provides high-level scripting for ETL. When dealing with machine learning applications, the legacy MLLIB focused strictly on RDDs, while the modern Spark ML offers a higher-level library with advanced pipeline support and seamless data frame integration. The Hadoop ecosystem encompasses 4 key areas: ingestion and storage, workflow and coordination, streaming, and serialization and query. This is a robust framework for managing diverse big data tasks. Dataproc is a managed Apache Spark and Hadoop service that abstracts open-source complexity. It boasts regional availability with an SLA of over 99.5% and offers per-second billing. Use cases span from big data processing to machine learning training. The Dataproc cluster is structured with a master node distributing workloads to primary and secondary/spot workers. The access layer includes a component gateway, Dataproc Metastore, and Spark History Server. Persistent clusters have a high ongoing cost and vulnerabilities, such as single points of failure. Ephemeral clusters are short-lived, cost-effective, and always deploy with fresh images. The critical maxim is to design for short-lived clusters. The core abstraction leverages Google Cloud Storage over HDFS, eliminating the 3x data replication overhead. This decouples the architecture, allowing compute and storage to scale and be priced independently. Raw data is ingested into cloud storage, the data lake, and then processed by Dataproc, the processing engine, for transformations and ETL. The transformed data is then loaded into BigQuery, the data warehouse, for analytics. When choosing a compute engine, use Dataflow for brand-new, cloud-native streaming and serverless continuous pipeline management. Use Dataproc for lift and shift migration or leveraging existing Spark/Hadoop expertise. Autoscaling mechanisms dynamically adjust cluster size based on metrics, using cooldown periods to avoid rapid scale changes. Spot VMs are cost-effective for ephemeral tasks, but are subject to preemption and offer no SLA. Optimization involves ensuring network proximity between clusters and storage, provisioning larger persistent disks for optimal IOPS, and optimizing I/O by using columnar storage formats. Utilize dist-CP for efficient bulk data transfers. Shuffle is network I/O redistribution between partitions. Advanced execution includes Spark 3 adaptive query execution, which dynamically optimizes query plans at runtime for performance, although it adds complexity. The migration path to cloud-native optimization involves a storage shift, compute shift, ecosystem modernization, and finally, cloud-native optimization. The goal is total decoupling of compute and storage. Comparing languages for Spark, Python offers ease for prototyping, while Scala is fast for high-performance data engineering. Java suits enterprise integration, and SQL is ideal for data warehousing and BI. Security and governance are enforced by VPC service controls and customer-managed encryption keys. IAM least privilege strategy ensures roles like editor, viewer, and worker have appropriate access levels. Monitoring and logging track job metrics, CPU, disk IOPS, and network utilization, with centralized logging for job output. Google Cloud Dataproc acts as the managed engine, bridging the open-source ecosystem with cloud-native scale. It processes real-time data streams from Kafka into the cloud storage data lake, uses Spark for computation, and loads results into BigQuery for analytics.